Hi everybody, welcome back. We're going to start our next unit, which is Unit 3, which is functions. Today our topic is going to be on functions versus relations, okay? A lot of this is going to be vocabulary, and some of it may even be a review for you guys, okay? So we're just going to go ahead and get started then. Cool? So, name that vocab word. We're going to go ahead and do a lot of vocab, alright? Now, on your piece of paper, there are 5 words, and then underneath it, it's got a graph and a bunch of arrows coming out of it where you can label the parts of the graph as well. So not only are you going to do the definition, you're going to label the graph at the bottom of the page as well. Okay? And I'm just going to do that all in one slide. So let's go ahead and get started. So please ignore this little 1 thing. No need to see that. Alright, so first word is coordinate or Cartesian plane. This whole thing is a Cartesian plane or coordinate plane. It's a plane made by the intersection of horizontal and vertical axes, plural, whatever. So please label this whole thing as a Cartesian or a coordinate plane and make sure you write down the definition. I believe the next word you have is the x-axis. The x-axis is the horizontal axis of the coordinate plane, okay, which is this one right here. So please make sure you label that. The next word is going to be the y-axis, which is the vertical axis. Vertical axis, the one that goes up and down. You can remember this. Think of it like the y is a much taller letter, and the x is a much fatter, wider letter. That's why the horizontal is much wider and the vertical is much taller. Okay? Then the next word you have is origin. That's the intersection of the x and y axis, and it's got a really nice ordered pair. It's 0, 0. So it's basically, if you think of each axis as a number line, it's the middle of each axis. Okay? And the last one is quadrant. Quadrant are the 4 sections made by the intersection of the x and y axis. So here we have 1 in the top right corner. Top left is 2. Bottom left is 3, and bottom right is 4. Please make sure you label all these. I would label them on the graph as well as off to the side so you can keep them straight. But if you notice, if we go in order, 1, 2, 3, 4, it makes a C. Makes a C, just like the name. A coordinate plane. Okay? So, if you didn't get it all, pause the video. Pause the video if you need a few more seconds to write it down. Okay? Alright, let's go ahead and move on. Next thing we need to label and define is this thing. Okay? It's called an ordered pair. It's the placement of a point on a coordinate plane. So, it's kind of like, it's like the latitude and longitude of math, kind of, where it gives us an exact location of where something is. So, actually, latitude and longitude is pretty much an ordered pair. Alright, and then we have the x-coordinate, which is also known as the abscissa. I will rarely refer to it as that. It's just a vocab word you need to know. Which is the x value of the ordered pair, so the first number. And the y-coordinate, or the ordinate, which I like to say, coordinate, is the y value of the ordered pair, so this guy. Then you had to go ahead and label the parts, so this whole thing is called an ordered pair. This is your abscissa, or x-coordinate, and this little doozy right here is your ordinate, or y-coordinate. Okay? Next thing. Alright, so the big chunk, that was all mostly review. Here's the big stuff, the new stuff. Not really new, but we'll call it new. This is what we're going to be focusing on. A relation. A relation is a set of ordered pairs. Now, we can represent it not necessarily as ordered pairs, but our representations, we can make ordered pairs out of them. So, but it's just a bunch of ordered pairs. That's all a relation is. Okay? And here's an example. 1, 2, 3, 4 ordered pairs. It's just a set of them. Can be random, can be a specific reasoning why we have those ordered pairs, but just needs to be a set. And dun dun dun! A set, any set, must be in braces. So when you list your ordered pairs, you're always going to put a comma in between them. And then on the outside, you put braces. Make sure you do that, because that could cost you a good point or two if you don't do it. So, okay. Now that we know what a relation is, what about a function? So, is this a function? We don't know. We don't know what a function is. So let's find out what a function is. A function is a specific kind of relation. So it's still a set of ordered pairs, but it's got an extra rule to it. Okay? That extra rule is every x value is matched with only one y value. Okay? So every x is only appearing once in a set. Alright? So, good rule of thumb, every function is a relation. Not every relation is a function, though. Okay? Because every function is just a set of ordered pairs. But the functions have an extra rule. So not every relation is going to be a function. So our big thing today is to figure out if something is just a relation, or if it's that extra step and it has that extra rule and it's a function. So we have to tell, is this one a function? When we look at the x values. We have a 9 that's only matched up with an 8. We have a -3 that's only matched up with a 4. And we have a 1 that's only matched up with a 2. So because each x value is only matched with one y value, it is a function. Okay? Let's talk about what would happen if we wanted to add to this set. If we wanted to pick another ordered pair. If we picked another ordered pair, that ordered pair could keep the whole relation as a function, or it could make it not a function anymore. Alright? If we wanted to keep it as an ordered pair, we have to, not as an ordered pair. If we wanted to keep it as a function, we still need to follow that rule where every x is only matched with one y. So if we're going to pick an ordered pair to put in there, it can't be a 9, a -3, or 1, because those x's have already been matched with someone. So we need to pick another x. So, like 2. That x has not been used yet, so we can pick that one. It's still a function. Now, it's okay if the y's get matched twice. That's okay. That's like 2 people can go to the same party, but one person can't go to 2 different parties at the same time. Okay? So if you think of it like the x is your person, and your y are your parties, an x can't go to 2 different y's, like a person can't go to 2 different parties. But 2 different x's can go to the same y, because 2 people can go to the same party. Okay? So that's why 2, 2 will work. But if we wanted to pick one that would make it not a function anymore, if we pick the same x and a different y, it'd be matched up with 2 different things. Like -3 is now matched with the 4 and the 1. So because it's matched with 2 different y's, it's no longer a function. Okay? Okay. Other ways we can show a relation. So a relation is a set of ordered pairs, but like I said, there's multiple different representations for ordered pairs. Okay? We can use mapping, which basically just takes your x's, puts them in one bubble, your y's in another bubble, and we use arrows to show what's matching. Okay? You can tell if something's a function from mapping if your x's are going to have 2 different arrows coming out of them, because that means they're matched with 2 different y's. Alright? But if every x only has 1 arrow coming out of it, it's only matched with 1 y. So that's how you can tell if it's a function or not from mapping. From a table, that's our next thing. Okay, that's the other way we can represent an ordered pair, where the x coordinate from the ordered pair would go in the x column, and the matching y would be right across from it. Okay, now you can tell if the same x appears in the whole table, so like I have 1 here and 1 here, but the y's aren't the same, that's how you know it's not a function, or the y's aren't the same, that's how you know it's not a function. But if every x only appears once, and the y's are only, like, they only are matched with 1 y, they don't have, like, if the x only appears once, it's a function, okay? And then a graph. Oop, forgot to write that. A graph. That is another way to show a relation, okay? Because ordered pairs, the whole point of it is it shows a point on a coordinate plane. So if we plot the ordered pairs on a graph, we can still see what all the ordered pairs are, okay? So that's the other representation of a set of ordered pairs. It's just to plot them, okay? Now graphs are a little bit, not more difficult, it's just we have to look at it a different way, okay? With graphs, we actually use a rule, the rule called, let's see if I can get it, yep, the vertical line test to determine if a graph is a function. And that just says we draw a vertical line through each point, or if it's continuous line, we pick a bunch of points. We draw vertical lines through them, and if what's on the graph right now only goes through our vertical line that we drew once, then it's a function, okay? So, but if it hit more than once, if I drew a vertical line here and I had 2 points on it, that means 2 points have the same x value, okay? Because the vertical line is just going straight through an x value. So that means if it has 2 x values with the same, or I'm sorry, one x value has 2 different y's, it's not a function anymore. So it has to pass the vertical line test in order to be a function for a graph, okay? So now you're going to do these next 3 are on your sheet of paper. They're to try on your own. You have to determine if these are a function or a relation just by looking at it, okay? So you have a table, you have mapping, and I labeled them for you so you know these are the x values, these are the y values, and a graph. And I was very nice and I drew a vertical line for you, okay? So looking at these kind of things, you have to determine if it's a function or just a relation, okay? So I'm going to give you a few minutes to go ahead and do that. It's yes or no, that's all I need. Or, I'm sorry, not yes or no. Is it a function or relation? Right, function or relation? I wasn't paying attention to the question. So go ahead and pause the video. When you come back, I'll have the answers. Okay? See ya. Alright, so this table. We look at all the x values. We have a 9, a 4, a 0, and a -5. There's no repeats of the x values. Okay? So because there's no repeats, it is a function. Where did I write? Yes, it is a function. Okay? It's okay. It's still a function even if all the y values repeat. Just like 9's going to the ones party, 4's going to the ones party, 0's going to the ones party, -5's going to the one party. That's okay. Alright? 4 people can go to the same party. Alright, let's go on to the next one. Is this a function? Well, if we look at this, mapping is really nice. I think mapping is the easiest way to tell if something's a function or not. Okay, we have -7 going to the 4, we have 0 going to the -2, we have 0 going to the 5, we have 2 going to the -2, and we have 14 going to the 4. Because 0 is going to both the -2 and the 5, it's like 0 is going to 2 parties, 2 different parties at the same time. He's promised -2 and 5, he's going to go to their party. That's not going to happen. He's not going to be able to function in that lifestyle, okay? So, because he's got 2 y's he's matched with, 0 caused it to not be a function. So no, it's not a function. Not a function, okay? And our last one, is this a function? Well, it's a graph with draw the vertical line. So I just picked where to draw a vertical line. And you see how it only crosses here once? Right here? That's the only time these 2 lines cross, right? Because it only crosses once, it is a function. So yes, it's a function. Okay? So that's it for the notes today. Just function versus relation. If you have any questions, please make sure you star them. And I'll be happy to go over them next time in class. I'll see you guys later. Bye.